The red planet's tiny, misshapen moons Phobos and Deimos are widely believed to be captured asteroid, but a new theory claims they may once been part of the red planet. Researchers modeled the effect of a giant impact on the red planet, and now believe it may have formed the moons. The simulations showed an object with roughly the mass of Pluto would throw around 1,000th of Mars's mass into orbit. Julian Salmon of the Southwest Research Institute in Boulder, Colorado revealed his theory at the Lunar and Planetary Science Conference in the Woodlands, Texas, last month, according to New Scientist. If the moons were asteroids, they would have less regular orbits, the researchers say. Now Salmon and his colleague Robin Canup adapted models used to study the formation of Earth's moon, which is also thought to be the result of a large collision. On Mars, the collision would throw around 1,000th of Mars's mass into orbit, and the edge of the disk would reach beyond the 24,000-kilometer orbit of Deimos, the outer moon. Although nearby material would be dragged back to the Martian surface, the team found the outer part of the disk would spin fast enough to keep it out of gravity's clutches, meaning the material could have formed into the Phobos and Deimos we see today. The idea is that Phobos and Deimos are the only two survivors of a once much larger population of satellites, said Salmon. Such a large object hitting Mars in its past could also explain some other features we see today, like the planet's relatively fast rotation and the large differences in average surface height between its northern and southern hemisphere, says Salmon. It makes sense to think about a big impact for Mars. In late November and early December, the space agency's Mars Atmosphere and Volatile Evolution mission made a series of close approaches to the Martian moon. This allowed it to collect data from within 300 miles, 500 kilometers, of the lunar surface, as well as produce spectral images of Phobos in the ultraviolet. The images will allow MAVEN scientists to better assess the composition of this enigmatic object, whose origin is unknown. Comparing MAVEN's images and spectra of the surface of Phobos to similar data from asteroids and meteorites will help planetary scientists understand the moon's origin, whether it is a captured asteroid or was formed in orbit around Mars. The latest theory is that Phobos was formed in a similar way to our own moon, in something known as the giant impact hypothesis. This states the moon formed shortly after Earth was formed 4.5 billion years ago when a large object, around the size of Mars, collided with our planet. The material that was thrown out from this collision rapidly combined quickly after the impact to form the moon. Some researchers, however, argue that Phobos was once an asteroid that got drawn in by Mars' gravitational pull. The MAVEN data, when fully studied, will also help scientists look for organic molecules on the surface. Evidence for such molecules has been reported by previous measurements from the ultraviolet spectrograph on the Mars Express spacecraft. Last year, astronomers from California predicted that Phobos will eventually be destroyed by its parent planet's gravitational force. Once destroyed, the satellite's remains will encircle Mars, causing it to become a smaller version of Saturn and the first non-gaseous planet in our solar system to sport rings. In a paper published on Nature Geoscience, the researchers from the University of California, Berkeley explained how Phobos and the red planet are on a collision course. Unlike our moon, Mars' main satellite is moving closer and closer to its parent planet, which is inexorably pulling it down. This gravitational tide is opening grooves on Phobos' surface which can measure 328 to 656 feet, 100 to 200 meters, wide and 33 to 98 feet, 10 to 30 meters, tall. The scientists attempted to calculate whether the moon would eventually just crash on the red planet, or rather break into pieces. Combining observational data with a computer model to calculate the internal strength of Phobos, they found that much of the satellite is composed of weak materials, which makes its disintegration almost inevitable. Phobos might not be the only doomed moon in our solar system either. We speculate that diminutive Phobos may be the last of many inwardly migrating prograde satellites in our solar system. The researchers wrote in the study something similar could be happening, for instance, to Neptune's moon Triton, which is also slowly losing orbit and has comparable fissures on its surface.